Okay, we're going to see if this works. This is my first time using the right pad, so it's going to be pretty sloppy. And I don't have graph paper. I haven't figured out how to get the graph paper yet. Okay, so we're looking at homework 36. Let's do number 3 from tonight's homework. Sorry, sloppy. Y equals x squared minus 6x plus 8. Sorry, it's messy. Let's make a t-table. We want to find the vertex. We want to find the y-intercept. And of course, we want to find 2 more points. Sorry, I'm just learning how to use this right pad, so this is a dry run. So let's have our vertex work. Hopefully your paper isn't as messy as this one. This wouldn't be that excellent quality. So A is 1. B is -6. You can't see it up there, but it says negative. And C is 8. Even though we don't use C in this equation, I wanted to put it up there because it's good for later on. So to find the x-coordinate, we need to use the formula -b over 2a. Oops, b's not 0 in this problem. I need to erase that. Oops, oops, oops. So -6, there we go, over 2 times 1 is 6 over 2, which of course 6 divided by 2 is 3. So that means we know that the x-coordinate is 3. I don't know if you can see that. I didn't realize that that wasn't going to show up. To get the y-coordinate, we need to plug in 3 for x. So that's going to be 3 squared minus 6 times 3 plus 8. Always do exponents first, so it's 9. -6 times 3 is -18 plus 8. 9 minus 18 is -9 plus 8 is -1. So now we have our vertex. I have a funny feeling you're not going to be able to see the bottom. Oh, okay, here's our y-intercept. Let's draw a line through that. Sorry. So what do we know about the y-intercept? Doesn't the x always have to be 0 if you're looking for the y-intercept? Yep, that's right. So 0 squared minus 6 times 0 plus 8. So it's 0 minus 0 plus 8, which is just 8. Plugged in 0, we got 8 out. So before we find our 2 other points, maybe we should graph this and get a little sketch of this and see what's going on. And unfortunately, I haven't figured out how to use the graph paper yet. So I'm going to have to make one. But I noticed 0, 8 is my y-intercept. So maybe I should lower my x-axis, given that I can see I got to go all the way up to 8. Isn't it so much nicer when you have graph paper? Ugh. I hope you all bought your graph paper. What did you guys have for dinner today? As I'm making this graph paper, I hope you're ready for this new chapter. It's going to be pretty intense. We're getting a little bit behind. We're going to start picking it up. Okay, so we're going to start graphing. So we're going to graph the vertex. and the vertex is 0, -1, but I accidentally plotted 0, +1. So I have to erase that because I went the wrong direction. I bet you do some that sometimes too. We all make mistakes. Now I'm plotting the y-intercept, 0, 8. And it's a good idea to draw in the axis of symmetry because that helps you use the idea of the symmetry of the parabola to get some other points. All right, so there's my beautiful axis of symmetry. And whatever the distance is from one side has to be the same distance. That looks, I'm eyeballing that. So I can see that opening is also up because the A is positive, so I know the parabola is going to be going up, so that looks about right. And I've decided that my two other points, x is 1 and x is 2, would probably be a good idea to pick those two values. I really could have picked anything, but 1 and 2 for x seemed like a good idea. So we're going to do y equals 1 squared minus 6 times 1, getting a little bit better, plus 8. So it's 1 minus 6 plus 8, -5, and that gives you 3. So 1, 3 is the vertex. I'm sorry, that's another point. And then we got to do the mirror image on the other side since the parabola has symmetry. And let's plug in the other point. We said we were going to pick 2, so we got to do 2 squared. As you're doing this, are you guys using the right notation? Are you using the parentheses to emphasize that you're substituting in 2 for x? Sorry, that one was a little sloppy. Plus 8, can't see it off to the side, but you know what I'm doing. 6 times 2 is 12, plus 8 gives you -8. Plus 8 is 8 and 4. Is that really 12? Yep. Okay, just checking. So that's 2, 0. Let's plot 2, 0. There we go. Oh, those are my x-intercepts, aren't they? Look at that. Those are my x-intercepts. Got a nice parabola. Do the best I can with freehand. Oh, oh, oh. Yeah, it's not that great, but you guys will be using graph paper, so it'll be better. Did you put your arrows? Don't the arrows show that it keeps on going continuously? This is a continuous graph, isn't it? It's not discrete, it's continuous. Throw in another vocabulary word in there. What about the equation for the axis of symmetry? What is that equation? X equals 3, yep. And that is the axis of symmetry. I don't know if you're going to be able to see that, but up at the top I'm writing axis of symmetry. So we've got a beautiful sketch of the parabola. We've got the axis of symmetry. That's x equals 3 is the equation associated with that axis of symmetry. And what about a maximum or a minimum? Does the parabola have a max or a min? Right? It's going to have a minimum. Because remember, minimum describes how low the parabola will go. And isn't the lowest point it goes -1? So we say the minimum is -1 because that's the lowest the parabola will go. And then there's our beautiful x-intercepts. Those are also extremely important. So let's point those out. And the x-intercepts are also known as the solutions to a quadratic equation. So when you find a solution to a quadratic, you're really finding the x-intercepts. Okay, let's see if this one took. Okay, I hope this works.